Good morning, class. Happy Wednesday. Welcome to today's math lesson. Today, we are doing a really cool thing. We are going to basically put everything that we know now together to find unknown angles, okay? So our task today is to find unknown angles. And so we have to use all the tools that we have in our tool belt to find these unknown angles. So I just want to remind you that you have these anchor charts to help you out. So these are the original rules that we learned with the sum of angles of a triangle being 180 degrees, okay? And the sum of the angles opposite a right triangle, opposite the right angle of a right triangle is 90 degrees. And then the exterior angle of a triangle is equal to the sum of the opposite interior angles. So these two add up to equal this one, okay? As well, don't forget we have these two rules. Okay, the two angles facing the equal sides are equal in an isosceles triangle. So you can see how that works. And then for equilateral triangles, all of the angles are 60 degrees. And that is always true for an equilateral triangle. Okay, so we have these sets of rules. And I also want to remind you of the rules that we learned about angles earlier this year. So vertically opposite angles are equal and the sum of angles on a straight line is 180 degrees, okay? So now that we have all of our rules, we're going to apply them. So please open your textbook to page 64, okay? And we are going to tackle questions 6, 7, and 8 together, okay? So you just need to have this page open and be giving me your best attention. And you're welcome to try to fill in answers for yourself in your own head, but obviously I will be walking you through this whole process today, okay? So let's look through the first question. Number 6, in triangle PQR, QR equals PR, so those are the two lines that are marked, and PQR is 65 degrees. QRS is a straight line, so find the angle of PRS. Okay, so it's telling us all the information that we need. So we have our two equal sides from here and here, and we're given one angle. And so we have to find this angle here. Okay, so let's do that math. So it's telling us we have two equal sides. So right away, bing, 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 we should have isosceles triangle rules in our head, okay? And because angle PQR is across from one of the two equal sides, we know that angle QPR is also 65 degrees. So we have angle PQR given to us, okay? But angle QPR is also 65 degrees because those two angles make up the pair of angles for our isosceles triangle. So it's like that's matching set because those are our two equal sides. Okay, if we turned our textbook. Okay, and so now it's time to apply a different rule because we have two angles that are across from an exterior angle, which we have a rule about here. Our exterior angle is equal to the sum of the two angles opposite inside. So if we had our triangle, we've got these two angles, and obviously this is not to scale. We've got these two angles, 65 degrees, because we know that it's an isosceles triangle. And so all we have to do to find angle PRS is to add these two angles together, okay? Okay, which of course is going to give us 130 degrees, okay? So do you see how that works? So we had to apply two rules to find the missing angle. And the thought bubble even gave us the first rule for an isosceles triangle. But we found the unknown angles that we needed to in order to get the answer that was asked of us. Okay, so that's our strategy for finding unknown angles. Okay, let's keep going. Let's see what number 7 says. in the figure, AB, so these are lines that it's talking about, AB equals AC. Okay, so we can see we have another isosceles triangle right there. Okay, and angle CDE is 75 degrees. So this is an exterior angle and it's tucked over here. BCD, so this line, and ACE, that line, are straight lines. Find angle ABC. So this angle down here at the bottom. Okay, so this is where you have to look in our tool belts and remember that vertically opposite angles are equal, okay? So if we have, so pretend we just have like our little crossing here, right? So across from each other, these two straight lines, so this angle tucked in the corner, angle ACB, is the same as angle DCE, okay, which is 75 degrees. So this isn't our final answer yet, but the angle that's opposite of DCE, which is ACB, equals 75 degrees because vertically opposite angles are equal. Okay, so that's how we figured out this angle here. And now we can apply our isosceles triangle rule, okay? Because this angle is one of the matching angles in an isosceles triangle because it's across from one of the two equal sides. Okay, it's facing one of the two equal sides, which means that because ABC is also one of the base angles that's facing one of the two equal sides, they are partners. They're matching. They are going to be the pair angles, which means that our answer, angle ABC, also equals 75 degrees. Okay, so there is our answer for 7. Okay, so because we used our vertically opposite line angle rule to find this one, and then we used our isosceles triangle to find this one, we know that our answer is 75 degrees. Okay, so that's number 7. So now number 8 is throwing a lot at us. We have 5 questions to look at, and we're going to need to figure out which rules we have to use for each of the triangles. Okay, so it's telling us that BCD is a straight line in each figure, and it's asking us to find the unknown marked angle, okay? So they're all labeled. So we're looking for angle A, B, C, D, and E, okay? They're marked with small letters. So let's start with this one. Let's figure out how to find angle A. Okay, so the only angle that we're given is 50 degrees, and that's angle BAC. Okay, but we see that we have our two little dashes to tell us that this is an isosceles triangle. You see that there on line AB and BC? And the 50 degrees of BAC is across from or facing one of the two equal sides, which tells us that this angle, angle ACB, is its counterpart. It's going to match it as well because it's the other one that's across from the equal side. Okay, so for A, we have angle BAC equals 50 degrees. That's given to us. But angle ACB also equals 50 degrees. And we found that out because we know our isosceles triangle rule, okay? With the equal sides and the equal angles, okay? And then you'll notice that we have the angle that's adjacent to A. And because we know that BCD is a straight line, we can actually use our rule about the sum of angles on a straight line. Okay, and to find A, we just need to do 180 minus 50 degrees. Okay, which is going to give us 130 degrees. Okay, So there is the first triangle. And you can also use the rule about the exterior angle if you wanted to, but then you would have to find this corner angle here. Okay, so it's just easier because we've been giving the angle right next to it to use the straight line rule. Okay, so let's look at B. So B, we're asked to find this little peak angle right here. And the only information we're given is 110 degrees. And again, we know that BCD is a straight line. So the angle ACD is 110 degrees. So we'll start by writing that down. ACD is 110 degrees. Okay, so that's the information we're given. And now, think about what rule you might have to use to find some more angles so that we can get to the missing angle that we need. Okay, so we know that it's an isosceles triangle. And the angle that we're looking for is the odd angle, okay? Because it's sandwiched right between the two equal sides. This is the third angle. That is not part of the matching angles that are going to be these two angles, okay? So if we find the value of ACB, that means we can find the value of ABC, and the remainder will be our missing angle B, okay? So in order to find the base angles, we can use our straight line rule, okay? So we have ACD is 110 degrees, and so 180 degrees minus 110 degrees equals 70 degrees. So that's ACB, okay? So we found that out using our straight line rule. ACB equals 70 degrees, okay? So that's this angle right here. So that's not where we need to end up. We have to keep going. And because we know it's an isosceles triangle, this angle is the same as this angle because they're across from the equal sides. So angle ABC is also equal to 70 degrees. Okay? So now we just have to find the value of the third angle because we have these two angles now. Okay? So to find angle B, we're going to do 180 minus 70 minus 70. Okay? Which is going to get us to 40 degrees. And there is our missing angle. So you see how we had to apply a couple of rules there to find the unknown angle. And we had to find some extra angles too, which is fine. Okay? So let's look at C. C, we see 3 ticks, which means that this is an equilateral triangle. And our rule about equilateral triangles is that all of the angles are 60 degrees. Okay? So we know that all of the angles inside this triangle are 60 degrees. Okay, but it's asking us to find angle ACD. So this little C here. So this, again, we can just use our straight line rule because we know that this angle is 60 degrees. Or we can also do the vertically opposite angles, these two corners, because they're also 60 degrees. So either you add these two 60s together to get C, or you can do 180 minus 60. It's the same. It's going to get you to the same place. So there's 2 options for figuring out C. But our final answer is going to be, and I'm going to do 180 minus 60. Okay? I'm using the straight line rule. And the answer is 120 degrees. Okay? So we've just got 2 more. So this one, D, is a teeny tiny angle. So it's also an equilateral triangle forming the base of it. So again, we have our 60 degree rule here on the inside of the triangle. But this time, we're also given this angle, the ACE, which is equal, and we know this by the box, to 90 degrees. So this one, we can kind of use this triangle to help us figure out this answer because we already know that the angle ACD, this big angle here, is equal to 120 degrees. We found that out with question C. So all we need to do here is subtract our right angle from it to find D. So we're going to do 120 minus 90, which gives us 30 degrees. So angle D, this tiny little angle in here, is 30 degrees. Okay? All right, last one. So we've got a few things going on. We've kind of got two triangles here, and we know that this one is an equilateral triangle. Okay? So all three of these interior angles are 60 degrees. Okay, so we're going to have to think about what rules we might need to find angle E. Because angle E is not isosceles or a right triangle or an equilateral triangle. This little triangle here is an obtuse triangle. So the only way we're going to find E is if we find the angle ACD, because ADC is labeled as 40 degrees. So we need ACD, this corner, and then we can subtract them both from 180 to find this corner. Okay, so I'm going to use the straight line rule again, okay? Because we know that all of the inside angles are 60 degrees, so angle ACB right here is 60 degrees, okay? So then with my straight line, angle ACD is also going to equal 120 degrees. Okay, and I'm going to put that note over here. Angle ACD equals 120 degrees. Okay, so that's what we found together. And we know that ADC, this is the one they've given us, is 40 degrees. Okay, so now we have two angles out of 3 for this squishy little triangle on the side. So now to find E, we just have to use our triangle rule, which is that the sum of the angles in a triangle add up to 180. So we're going to take 180 and we're going to subtract 120 and 40. And that is going to give us 20 degrees. Okay? So there's all of our textbook problems. So I'm going to put that away now because it's your turn. Okay? Today, your task is to do workbook exercise 43. Okay? And it's 2 pages long. Okay, so you have 8 triangles to work on. And when you're doing these questions, I want you to use the anchor charts that you have, right? To remember the rules that you can use to find the answers, okay? So we use the rules we know about isosceles triangles, as well as the values with that one. And don't forget these 2 rules, okay? The sum of angles on a straight line is 180 degrees. And vertically opposite angles are equal, okay? So please use those when you're trying this. And of course, if you have any questions, you're welcome to reach out to me, okay? But you've got this.